Hello, everyone. Hey, it's Aurora here for some deep learning. I'm very pleased to be here. It's been a while since we've done one of these. And I have a lovely guest today. So deep learning is the Battlesnake show where we do a deep dive into the learning, the educational journey that is Battlesnake. I think all of us, when we build Battlesnakes or we're looking to start building Battlesnakes, we realize there's so much to learn and so many opportunities to grow, and it's a lot of fun. So deep learning is our chance to explore that and have a focus on that aspect. Today, deep learning, as well as our other Battlesnake shows, are definitely built in support of our wonderful sponsors. So a shout out, a thank you to our 2021 annual partners, AWS, RBC, and Replit. Thanks to them, we get to do fun stuff like this and hang out with you wonderful people and put these shows on and do Battlesnake stuff. So very excited to do that, which is nice. So today is an interesting and special day. So for those of you who may or may not know, so Battlesnake HQ is located in Canada. We're in BC, Canada. What's special about today is this is the first year Canada's recognizing the National Day for Truth and Reconciliation. And it's a day for Canadians to kind of learn and reflect on what's honestly a rather dark and painful chapter of Canadian history, specifically around the impact of a residential school system that Indigenous children were forced to attend. So even though Battlesnake is very much, we're an international, we're a virtual sort of system, and we have viewers and participants from around the world, because Battlesnake is located in Canada, I thought just today for the stream, it would be appropriate to just take a moment and reflect on the physical place that Battlesnake is located in and give a land acknowledgement. So what a land acknowledgement is, for those of you who may not know, is it's a traditional, or sort of like, it's a protocol really, that's carried out by Indigenous communities in Canada. And it's intended as a way for guests to show their respect for and to pay homage to the Indigenous communities that they are visiting and engaging with. So for that, I would like to acknowledge and respect the Lekwungen speaking peoples on whose traditional territories I live, I work, and I'm currently streaming from. And the Songhees, Esquimalt, and Wasanic peoples whose historical relationships with the land continue to this day. So very grateful to be in British Columbia and able to live and stream and Battlesnake from here. So thank you for that Canadian a moment there for us. So without any further delays, I would love to bring up our new topic for today's deep learning. So I have in the background with me Austin, who works for RBC and is the developer behind RBC Serpent, who you may have seen. He was the winner of the Spring League Gold 1v1 tournament, which is fantastic. And something that I think is interesting is for Battlesnake, we focus so much on like the platinum champions and the people who are like hardcore into machine learning. But the truth is most of us are still in this process. The majority of people who enter a tournament are reaching or moving in that gold level area. And that's a different mindset and a different learning stage. And I really wanted to focus on that. And I thought maybe Austin would be a great person to tell us what it takes to win gold, win that gold tournament. I think that's a beautiful place to be. So Austin, let's bring you up here. Welcome to Deep Learning.
Hello.
Oh, it's just got a little delay in your video here. Hello, let me remove and add you again. That was not as dramatic an entrance as I was hoping for. There we go. Here you are. Sweet. Austin, welcome to Deep Learning. Thank you for joining us.
Oh, thank you for having me.
So I think, as I was saying, I think like gold is a really interesting, it's an area that I would say most Battlesnake developers are currently striving towards. That's where we all are. That's where the pack is. Mm-hmm. So I want to find out your strategies, your approaches. Maybe let's look at what you did. But let's get some ground stuff. Who are you, Austin? What do you do?
So I am actually a developer at RBC. I'm a junior developer. I just started recently, and I believe that my Battlesnake win actually helped me get the position that I'm in now at RBC. I started at RBC in a program called the Indigenous Peoples Development Program. So I am actually Indigenous. So today is a very special day, actually. And yeah, so that's how I found out about the Battlesnake tournament that RBC was having, and then from there I went into the Spring League, I believe it was, right?
Yeah, in Spring League.
It was a while ago, so.
Cool. I'm just going to bring up your profile here, Austin, just a second. And also see, I've got your video is pausing here. So let's see if I can. I'm just going to play with some buttons here, folks. Thank you for your patience. But I've got Austin's profile up here. Oop. Oh, we've got some video issues, Austin. We might be more audio focused, but I'll leave your video up in the hope that it connects again happily.
Okay.
But yeah, here is your profile. And we have 2 Battlesnakes here that you created, RBC Serpent and Ye Old RBC Serpent. So tell us a little bit about that journey, hey?
Yeah, so when I was developing the first one, the RBC Serpent, I was using the 1v1 tournament rules to test it and all that. The RBC tournament was actually a 4v4 snakes, and I didn't realize that it would be totally different strategies. So right at the very end, I had to create another snake, which I called the Ye Old RBC Serpent, I believe it is. And yeah, so I made a few minor changes to that to try and get it to work in the 4v4, or well, the 4 snakes, but it didn't turn out the way I had hoped. I think we're gonna get into that, right?
Cool. Yeah. And like some of those tweaks too were pretty quick. Like if I remember correctly, and this is a bit of an interesting story because leagues run for several weeks. Like we've just started Fall League and people are just starting to creep into silver at this point, right? Like it takes time to get enough points to get up to gold and platinum and so on. And I believe you joined with just like 2 weeks left.
Yes, I joined very, very late. I didn't realize it at the time, but yes, yeah. It was very, very late into it.
Yeah, no worries. Okay, very, very cool. All right, so sorry, I'm gonna take one moment here, Austin. I'm wondering if you could toggle your video on and off and just see if we can get you visually here so you're not just a ghost voice. Yeah.
Oh, there we go. I'm back.
There we go. Yeah, now you are a full human,
yes.
A voice, animated features. Lovely.
I think it stopped again though.
Oh yeah.
My screen's the same as yours.
Yeah. We got a little stuttering. Maybe just toggle that on and off a few times to keep an eye on that. Cool.
I will keep doing it if it stops.
Okay, sweet. All right. So fantastic. So you said you feel like Battlesnake is why you got your job at RBC. I'm very interested in that. Just saying, maybe Battlesnake is a path for people.
Yeah.
Very cool. So when you started approaching, maybe starting with the special RBC event we ran, how did you kind of approach coding your Battlesnake? What were the things you were thinking about? What were some of the stuff you tried? Maybe stuff that succeeded or failed?
So right from the very start, I never went into like strategies about like the different ways you can go about coding a Battlesnake. So I kind of just hopped right into it and tried to get something working. And then once I did, I just started adding things bit by bit to try and see how far I could get. And I think that's part of the reason why I managed to get so high in such a small amount of time. Because whenever I would find something that was going wrong, I'd fix it immediately and try and make it better so that it didn't happen again. And then that also helps because I think the way it works is you're placed against people who are kind of near you in the leaderboards. So there'd be a snake that would beat me sometimes, and I'd go in and I'd watch the games, and I had some outputs to see what was happening during the game. And I would take what that snake was beating me, I'd fix that, and then I'd rise a little higher, and then I'd get stopped up at another snake, and then I'd watch those games and see what they're doing different that was beating me. And then I'd go and I'd fix that. So it's kind of just a little hodgepodge of code here.
Nice. I mean, that's like classic iterative development, right? Like build your snake, test, see what happens, make changes, like iterate, keep cycling.
Yeah. But that's also where I shot myself in the foot because I was doing it with 1v1 and then the strategies when you have 4 snakes need to be a little bit different.
Right. Of course. Let's dig into that. So question, for building your Battlesnake, what tech stack did you use and why?
I chose to do C++ because when I was in school, I did a video game development course, which was very heavily C++. And I figured that knowing C++ and the different things it can do, it would be a good start to Battlesnake. Trying it with a language that I was already familiar with, but had a little bit of time away from. So it was nice to get back into it.
Nice. That sounds pretty excellent. How did you deploy? Like what were you using to host your Battlesnake?
I believe it's Replit.
Nice. Yes.
Yes, I wasn't sure.
What was that choice? Did you like want to learn Replit? Were you looking for speed?
I think it was speed because I only had 2 weeks. Well, I think I had a little longer than 2 weeks, but to get everything started and then also balance that with the work that I had to do, I just chose what was easiest to me. And then Replit, it was up and working very quickly. So that's what I rolled with.
Yeah, no kidding. All right. So I want to dig more into your strategy. I want to dig more into what you did, what you learned, but maybe let's like orient everyone here. So I was very lucky. I got to participate. So this is the leaderboard for the RBC Spring Tournament. So RBC, one of our partners, love you, RBC. We ran an intern tournament that Austin was a part of. And here's the winners and so on and so forth. And where are you, buddy? Here you are. You old RBC Serpent.
I'm at the very end there.
So let's take a look here. I think I have a game from that. Yeah, here we go. So Group C, Game 1. So let's just run. So yield RBC Serpent in the black. Shout out for the styling too. This is good. You've got a good emoji game. You've got a good name. You branded appropriately. So yes. According to Battlesnake lore, this should be a winning formula.
I spent a lot of time coming up with a name that I thought was clever.
But let's see how this game goes. Oh, just out like not even 30 turns there. So let's go back here. What do you? Oh, there's a lot of turns. Curtis is better at this than I am. So here's your RBC Serpent moving up. I guess it's going towards some food. Talk us through this. What do you think is happening here?
Yeah, so 30 is actually a very key number in my snake. So I try to avoid the edges of the board as much as possible, but before 30 turns into the game, I allow it to go onto the edge to collect as much food as possible. So I believe that's what went wrong. And part of that is because there's 4 snakes, there's more snakes on the edge. So it's not as careful.
Right. So it's just like plowing ahead for food. Will it do any kind of avoidance? Like if there was another snake in the border? Or would it just run right into it?
I think the RBC tournament was a little before the Spring League, so at this point, it may have not been checking for other snakes' heads in that position.
Yeah, totally. All right, let's see. I mean, you get a second chance. So we ran standard Battlesnake tournament format where we have these early group stages. So in the next one, Royal Bank of Poggers, also a good name. Won that previous game, removed. Let's see what happens in the second one. Do we have a similar elimination? Oh, you got past turn 30 here.
Ooh.
A little spin, little chicken snaking. Oh, even took someone out.
I did, yes. How do I go out in this? It looks like I'm doing so well.
Moving, I mean, greedy too, going for those foods. Currently branded as the pumpkin spice lattes for the fall theming here.
Wow, this was a long game.
Getting big. Oh no.
Oh, there it is.
No. So, I mean, there's some interesting things to see here, just rolling back the tape. So first off, this was a little sketchy to me because you're
bit, yes.
What do you think about that? What do you think was going through your battle?
So I have a recursive method in my snake that checks how many spaces are available, whatever direction you head in. And I only have it checking 8 squares ahead of time because I don't want to spend too much time checking the whole board, or else you'll run out of time. So, well, I get there was nowhere else for me to go at this point. So
That's true.
It was totally.
Yeah,
right
like
here,
back here.
I could have gone a different way here, but I think perhaps I was trying to collect the food. It's hard to know what my snake is doing because the way I determine my moves is very how do I put it? Not complicated, but it's a little bit complex to explain it. Maybe.
Yeah.
Yeah. So right here, I just got very, very lucky because I think I make it past this, right?
Yeah,
yes,
you do just barely.
I got very lucky that that I had space there to get out.
Yeah, when casting a game like this, that's when you're like, oh.
Yes.
And then finally, here, the fatal flaw.
Yeah. So I believe at this point, so the actual RBC Serpent that I put into the Spring League, I had to check for other snakes' tails. Here, I did not. So my snake was probably thinking that it had nowhere to go besides right, and to tie itself up into a knot there and have no space left.
Yeah. I feel like this is a really important learning moment in Battlesnake. Like, even if we say in advance or we give hints, you have to see it happen to be like, I got to deal with this case.
Yes.
Awesome. Okay. So, I mean, this is ye old RBC Serpent. This one got eliminated, knocked out in the showings. But then, I mean, there's a whole new story when we go to Spring League 2021.
Yes, it made me very happy.
Yeah. So the RBC Serpent, no longer old, managed to win it. And I believe you got some prizes for this.
I did, yes. I was very happy. I have the Alexa out in my kitchen right now, and I use it when I do my dishes. I listen to music with it.
Nice. But this is very exciting. I'm going to play a couple of games because I know the casters really enjoyed watching your Battlesnake because we were in the back channel. So often for leagues, I'll be generating games in the background. And we were just like chatting on our internal private line about what's happening. And we love the way your Battlesnake looked. We love the way how it's super creepy with its head and tail almost being identical.
Yeah, I wanted to go for intimidating.
Yeah. So let's take a look here at some of these games. There's a specific moment I want to stop here. I think, yeah, here we go. And around turn 60. Like, this was just like catching us. This was like, this looks like pants.
Yeah. Me and my mom were watching this tournament. Actually, I'm living with my mom because of the pandemic right now. We were watching this and we were laughing hysterically when you all mentioned that it was the RBC pant snake. Yeah,
for sure. I mean, this is just part of what makes some really good design choices. How can it impact your Battlesnake? But yeah, pushing us forward, I believe you swept this. So this final was first Battlesnake that gets to 3 wins, and you knocked it out in 3 games.
I got very lucky, I think. Because there's different strategies you can take wherever you coded one way and someone else coded another way, and that way just happens to be a little bit better than the way you've done it.
Yeah, totally. I mean, this is interesting. So like, even just watching this game, something I'm noticing is this Battlesnake seems a little less greedy to me. So I'm noticing like we've got a fair amount of tail chase and then kind of popping out for food when it's time. And then in the final definitive moment, you go for a head-to-head taking out. So, I mean, how much of that was deliberate, Austin? What's happening here?
So I make a check to see how long the enemy snake is, if their head is in a place where we can meet. So it's very deliberate moving into that space to try and knock him out there.
Nice. No, very good.
I think I go for a balance of passive and aggressive a little bit.
Interesting. Okay, yeah. Let's watch a new game here. I think this is your winning lap, as it were. And same sort of thing here. Yeah, we're seeing some early feeding. We're seeing some tail chase, classic chicken snaking, moving here. I feel like I want to pause here for a second. So here is good, but I can't help but notice. Sorry, this is the Battlesnake developer mentor in me. But I'm noticing there's quite a few tail chasing here where you're like one square away, which is a vulnerability.
Yes.
I think it's an expansion here, but you do, as we go forward, we do get that tightened up.
Yeah. So the only time that I allowed my snake to tail chase is if I'm longer than my opponent.
Interesting.
Yes. So I do some passive things and I do some attack things.
Little surround there. Yeah, it's interesting. It's like the tail chase followed by a brief eating frenzy.
Yeah.
Back into tail chase again. Yeah. And you can sort of see the opponent as doing something similar as well.
Very similar.
Oh, and then tangled up on themselves. Ooh. Yeah. And I wonder, same sort of thing here. So you weren't going to eat food. So up would be a valid move for Devsnake. They move up. Oh, and now you have a chance to eat food in the bottom.
I think I just got a piece of food there. Did I? Yeah, I collect all the food there. Yeah.
Totally. So it didn't matter. They had no choice. They either had to collide with themselves or with your RBC Serpent there. So taking it for the win. So, I mean, congratulations. Good work.
Thank you.
And taking it to an almost 400 turn game as well, which is very exciting and fun.
Yeah. Well, I remember looking at all the amount of turns that a game would have. And when it got up into the 300s and 400s, I was like, ooh, I want to watch this.
Nice. So what happened? What changed between the tragedy we saw and this like victory that you pulled out here?
Yeah.
What were you working on?
I believe that I put in the tail chase. Maybe I can't remember. There were a lot of little things that I did that made a big difference. I believe another one was trying to stay off the edge as much as possible. I can't remember when I put that in, but that may have made a difference.
Right. Yeah, which is very different from your like early edge strategy.
Yeah.
Were you watching games and just seeing that die out in the first 30 turns, or?
In the spring league, I was watching it whenever like I would be dying a lot on the edge, so that's why I tried to stay away from it as much as possible near the end. But in the RBC tournament, I believe that I realized, like, because I had been testing with 1v1 just for the spring tournament, and then I realized that 4 snakes is very, very different. So I think I only spent about 2 days testing it with 4 snakes, and I realized that it's much, much different, and what I was doing wasn't gonna be very well.
Right. These are all standard gates. I'm also curious here. I just want to crack open your latency graph here. I mean, this is pretty tight. So this is the entire winning game here. And we have one like, it's not displaying. Here, see if I can embiggen. Like one little latency spike here, but you're all like, for the most part, sub 100 milliseconds, just a couple up to 200. Is this something you looked at, or are you now just pleasantly surprised?
I looked at it a little bit, but I didn't go into depth with it. It's actually very surprising to me that it's so low. I thought that the recursive method would have that time a lot higher than it is.
Mm-hmm. When were you doing recursive checks? Was it just for like looking into space sizes, or were there other places you were using it as well?
So I did the recursive check just to see how many safe spaces I had if I went in that direction. So if I was going to tie myself up going one way and there was only 5 spaces available, like say if I were going right, and then the left, I only went to 8 spaces. So if I found 8 spaces to the left, I would say, okay, well, obviously we want to go to the left because we have a lot higher chance of survival going this way because there's more places to go.
Mm-hmm.
Yeah. And I used the way I thought about making the recursive method. I tried doing an A-star pathfinding algorithm, which is like finding the shortest distance to a certain position, but I changed it up a little bit to make it so that instead of finding the shortest distance, we were finding the biggest space available.
Interesting.
That was my idea anyway. That's what I kind of based what I was doing on. It's not A star exactly, but that's where my that's where I got it from.
That's interesting because normally when people talk about measuring space, it's always flood fill. Flood fill's the answer. Did you try flood filler as well, or is
no, I don't even know what that is actually. I never looked up any strategies, so I don't know. I don't even know what that is.
I love it. So you approached Battlesnake blind. You're just like, I'm gonna figure it out on my own.
Yes.
That is super interesting. I don't think I've ever heard of anyone using like inverted A star in that method.
Yeah, I guess you could call it that. Yeah.
That's very cool. I mean, I feel like now I want you to implement both, and I want you to measure the latency and see kind of the speed about what you get, whether or not this method is faster. Can you go deeper in one or the other?
Yeah, I actually tried increasing the amount of safe spaces that I would look for. I think at one point I had it way up to like 20 or something like that. And it was still fine. I forget what the exact latency was on it, but it was still making it perfectly fine. It's just that 20 was way too high and unpredictable. So, and it threw off I called it confidence ratings for which direction I wanted to go. And it threw my confidence ratings all off. So
there's your tweak.
I lowered it. Yeah.
Awesome. I feel like this is now a good transition because we chatted before and you agreed to be very vulnerable with us. Yes, and I appreciate that. Are you comfortable? Should we do like a bit of a code review? Let's take a look at the guts of RBC Serpent.
Yeah, absolutely.
Let's bring that up.
I wish my video would work more. It's in and out, isn't it?
Yeah, just popping in and out. Hopefully we got this on your screen share. Okay. Maybe give her a little scroll. Oh yeah.
It seems to be working.
Cool. So maybe give us an overview. I think whatever you'd like to talk about, either kind of like how you organized your code, or maybe if you want to zoom in on a part of your algorithm that's interesting, or I will also accept something that you're deeply ashamed of, so we can share and revel in the weird stuff that we all do.
Honestly, when I look at this code, I think it's a mess. So I'm deeply ashamed of how just messy and how much better this could be. I know that it's not the prettiest to look at, but I never expected anyone to look at it, right? So I just did what I was doing and didn't worry about it. So it's a little scary showing this, but we can definitely go through it. Yeah. Where should we begin exactly?
Wherever you'd like. Although chat, feel free. I know Austin and I have been very conversational, but if anyone has any questions for Austin or want to zoom in on something specific, let us know.
Absolutely.
Yeah. I mean, I'm definitely curious about your like inverted A star thing.
Should we go into that very first?
Yeah. Let's take a look-see. What did you do, dude?
Let's see. So I know that you should be breaking things out a lot more than I've done, but everything is kind of just sitting in 3 separate files that I used here. So if I had more time to do this, I think I would have went through and really made it more streamlined so that there's not all this chaos happening in the code, which you'll see once it loads here. But
yeah, Replic's being a little chunky here.
Just a little bit, yeah. It might be my internet too. Maybe that's what's happening with my video here.
Yeah. Give it a chance to load. Well, we can let that load in the background as well. So how did you sort of like, is this the same code base for both Battlesnakes, or did you start like completely fresh for your Spring League one? What was the journey there?
So this is my original code base here. And then when I realized that I would need to make a few changes for the RBC tournament, I duplicated this and then made the few changes that I needed, which obviously did not work very well. But after that RBC tournament, I think I just deleted the other code base. I'm not sure where it is, but it was the exact same as this basically. So,
fair enough.
And then I just focused strictly on this because I thought if I didn't win the RBC tournament, I at least want to do a lot better in the spring league.
Right.
Which I'm happy I did.
Nice. And definitely a question from chat here. So Titan asks, curious if you've built any tools or helpers to debug and test specific board states.
So I didn't build out any big tools, but if I can find something here, let me try and console. There's a few outputs that I have. I don't know if I have any in this method here, but I did do some outputs to the console with the turn number, and then I outputted all the information that I thought would be important to me. And then after each game, I would go through and look at the turn number and what was happening on the screen, and if something went wrong that I wasn't expecting, I'd go into the code and see, okay, why did this do that? And I'd use that output as my way to debug. So it wasn't anything fancy. And I don't know if I have any outputs here. No, I can't find any. We'll see it eventually when we look through the code. So, yeah. And then this is another part. I had color modifiers so I could see. I forget what color. Each direction had a color associated with it, so I could see quickly. Like I said before, I had confidence rating, so I could see what each confidence rating was and why it was going in that direction.
Ah.
Yeah. So that was my small debugging that I did.
Nice.
Yeah.
All right. So should we dig into your space checking inverted A-star?
Sure. So A-star, you use nodes to check each your path as you go, and then that node has it collects. Well, the way mine works is it collects the amount of free spaces that you have in each recursion of the method. So I have a node struct here that holds its position on the game board. And for the positions, I just use a pair because it's very easy to hold it that way. You have 2 ints, so it's just the coordinates for X and Y. So I just thought it was a lot easier. This is part of the reason why I use C++, is because I knew C++ had this pair and I knew how to use it. So that's why I went with this.
Nice.
I also have a string, so we know the direction of travel from, I believe it's from the last node. I can't remember exactly, though. I coded this a long time ago at this point.
That's fair. I mean, it's also looking like you hand-rolled the entire algorithm. You haven't brought in a library or anything to support?
No, everything I did was all me.
Nice. I mean, there's nothing wrong with using a library. High recommend.
Yes.
There are some fantastic pre-built algorithms, and when you're working on your Battlesnake, there are so many possible things to do. You have to choose where you're going to put your time.
Yes, absolutely.
So it's interesting that you chose this. You're like, I'm going to write this myself. I'm going to do this.
Yeah, and then that's another part too where I never looked up any of the strategies, so I didn't know that there was any. I'm sure I would have found some if I looked for it, but I just went with completely my own code just to see what I could do on my own. So
nice.
Yeah. So also in this node, you'll see a lot of me doing these nested pairs too. So the second part of this pair is the chords, and then the first part is the direction that those chords indicate. So this would be a string that holds the word up, left, down, right.
Right.
Yeah. So these are the valid neighbor chords for let's see, the move chords of this node's neighbor. Yeah. So I tried to comment it just so that I could read what it is quickly and not have to figure it out on the fly.
Yeah, this doesn't feel like organic commenting. This feels like
no, this is me doing it afterwards and trying to figure it all out again.
Yeah.
Yeah. So when I made it, none of these comments were this. It wasn't commented this much when I did it. That's for sure. Yeah. So also in this node, we have our previously checked moves so that it wouldn't just check in a circle and find the same 4 moves and count up to 8 and be like, oh yeah, this is safe. And then I'd go that way and I'd only have 4 different moves and tie myself up into a knot that way.
Right.
And then we have the valid directions that you can go from that node. So yeah, the 4 Boolean variables to determine if that direction is a valid move or not. Oh, and the safe move number. So this number here is the way basically the recursion works. So if I manage to get up to say 3 safe moves and then we found another safe move on top of that, I would increase this number for the next recursion so that when it went through, it knew, okay, now there's 4 safe moves in that direction.
Right. So question for you on this. So when you're evaluating, like as you go deeper and deeper evaluating safe moves, is it kind of taking like a snapshot of the board of how it looks at that time? Because like the walls are absolute, they're not going anywhere.
Mm-hmm.
But if there's like a snake, another Battlesnake body in the way, would it also like avoid that and just assume there would be snake body in there? Or
it does know about the snake bodies, but it doesn't know about the position of those snake bodies, of what they will be, based on how many safe moves it can find. So like if it can only find 4 safe moves, it doesn't move the snake that it found to try and figure out where that snake will be, if that's what you're getting at.
Yeah, and I mean, I'm not criticizing here, because I think that's actually, I think taking like that snapshot of the board at the turn where you're starting the evaluation, I think that's a good way to start, because especially with a long snake, there's a decent chance that if there's a snake body this turn, it'll probably be their next turn and maybe a few more in the future, right?
Mm-hmm,
the only exception is head and tail.
Right.
So if I was starting to build this, like that's definitely how I would do it, is I just start with that snapshot and then kind of move to improve from there.
Yeah, and I do hold all the enemy body positions and their heads in a vector to check against, so that I know that there's a snake body in that particular spot at that particular turn.
Very cool.
Yeah. So if we can, so this here is the node struct. This is what basically represents each grid space on the board, essentially. And then these are just my global variables here. So we have the height of the board and the width of the game board. And then this is just global variables that hold the amount of safe moves we found in each direction.
Oh, okay.
If I think I did things a certain way, this method is very confusing to me now because it's been so long since I've actually used it. Thinking back, I might have been able to use just the counter that was in the node, but at the time, I guess this just was the easiest way for me to figure out what one got up to the highest amount of safe moves.
Yeah, just like a convenient accessor.
Yeah. And then this was the number that I used as the cutoff point. So if I found this many moves, I would stop looking so that I didn't check the whole game board.
What made you choose 8 as like your cutoff?
So the way that my confidence ratings work, it adds and it increases and decreases the confidence based on what's going on the game board. So I check for 8 moves and then I times that number by 100 just to give me a bigger number to work with for my confidence rating. And then based on what's happening on the game board, increasing or decreasing it needs to be enough where if I were to decrease it by this amount, it has an effect on what's going to happen, right? So if there was one direction that had 8 safe moves and one direction that had 7 safe moves, but the if in the direction of 7 safe moves, if there was things that increased the confidence, and then if there was things the other way that decreased it, it could make a wrong decision and go the way that was worse than the other way. So 8 moves was just my kind of cutoff point where I could balance it in a nice way so that it
Almost
did
like,
what I wanted it to do.
yeah, so like an experimentally derived
Yeah.
sweet spot. Yeah.
Yeah, there was a lot of playing with all the numbers for the confidence ratings to get it to where I thought it was a good place.
Man, how many games do you think you watched in debugging?
Oh, I watched a lot. I had it on my phone and I would sit there on my phone and refresh it all the time. And if something happened, like if I lost one of the matches, that's the one where I'd go and I'd check it. So I was constantly checking and making tweaks, and I'd increase the number by a little bit, and then I'd watch it for a while and see, okay, this is not doing as well. So I'd go back in and change it back and change it to a different number and then watch it again. There was
Wow.
And I think that's another reason why I managed to get as high as I did in only 2 weeks, because I was watching it very, very closely. I was very invested in it.
Nice.
Yeah. So if we continue here, this is the actual check neighbors method. So this is the method. Let's see, what did I here? Check the nodes neighboring this one to see what direction move is safe. Yeah. So basically, we're just going into that node, looking at its valid moves from that position and seeing if those valid moves are safe to make or not. So if we look here, so if the current node's safe number for this particular direction is all right, so this is where I'm checking to see if this node's number is greater than the amount of safe moves, and if it is, we just we add that, we make that the new number of moves that's safe for that particular direction.
Okay.
And then this is where, if that amount of safe moves is 8 in this case, then we return from that recursive method, and then it's returning the number 8 there if we make it all the way to the end.
Nice. The magic number for RBC Serpent 8.
Yeah. Yeah. There's
Yeah,
lots
I think
of
you said 8.
numbers.
30 was a special number.
30 was a special number, yes.
Yeah, it's like
There's
this
lots of
Battlesnake
special
is
numbers.
partially powered by numbers of power.
Yeah. Okay, so then so this, if we haven't found 8 moves yet, then we keep checking. So create the valid moves we can make from this node's position. So this is a new node when we get to this point, and we don't know the next coordinates from this node. So this is where I'm creating the next coordinates for when we come back around and do this check again. So that's what all this is doing, is just creating the neighbors,
Nice.
the neighbor coordinates.
Whew.
Yeah, there's a lot happening. It gets a little confusing.
That's what happens when you roll your own algorithm, though. But like, what a learning opportunity and a chance to like practice and appreciate. Like, I'm sure all of us complain. You just like when you have to build like your own binary search tree or something silly like that. Like, it's a pain, but like doing it once is just so good for your brain.
When I was going through and creating this, I had such a problem trying to debug it, because when it gets into a recursive method, it's very hard to figure out where something had gone wrong. And because it's recursive, if it goes wrong near the start, it can get worse and worse as it continues. Right. So I had a very hard time with that.
No kidding.
So yeah, here we're just setting the opposite direction to false, because we obviously can't go back on ourselves. There's only 3 valid directions you can go on each turn. So that's basically all this is. And then here, so this is where, if a node is in the wall, we set everything to false, because we have nowhere to go from here. So I made this little diagram here to try and explain what I mean. So if this
is this original comment or something you put in later?
This is something I put in later.
Yeah. Okay. Fair.
It's kind of going into here, but it'll still make sense. So if this is the head of our snake here on the edge of the game board, when we create our neighbor nodes, the way it's working is it will try and look at a node that's in the wall here. And because that node doesn't exist, it doesn't matter what direction we go from there. Up. If we go up, we're still in the wall. If we go right, we're in the wall. So basically, all I do is if we're in a wall, I just set everything to false because we can't go any direction from there.
Right.
So that's all this is doing. And then, so this is a very nested for loop. There's a lot of for loops and if statements that are very nested. I know that's not a very good thing to do, but just in the
Sometimes you
small
gotta
amount of
do it.
time, yeah, in the small amount of time that I had, I just did it. So here we're checking our valid moves against the other snakes. So I believe this is checking for snake bodies, maybe.
Right.
Let's see, current position. Yeah, so this is just a for loop going through the 4 neighbor chords that we have. If any valid move has already been falsified, yes. So we don't want to check that direction if it's already been set as false. We can't go that way. Don't check it.
Nice.
The for loop to loop through the enemy snakes. Okay, yeah. So this is where we're looping through the enemy snake positions. So this for loop holds the actual snakes. So if there was 4 snakes on the board, this would be the vector that holds those 4 snakes. And then this for loop is the one that goes through each snake's body segments.
Right.
I don't know what the actual terms are that you use. Do you use body segments as terms? I just created all these terms myself.
Yeah, no, that's okay. My favorite thing is to make up new Battlesnake terminology and be very aggressive about it. There have definitely been casts where like sometimes the casters haven't said hazard sauce precisely. I'm like, it's hazard sauce. I like to think of it the whole body. There's the body, and then I like the neck. But when you think about that, arguably everything is neck. I don't know. I think it's funny and silly. But yeah, we usually call them body segments.
Okay, good. I was on point there then.
Yeah.
Okay, so if we continue, what is this? If this is our tail, it moves forward on each turn, so this will always be a safe place to move to. Yes. So in that RBC game that we watched, I believe if I turned, oh no, that was the enemy tail. Okay, so this is different. So this is for my own tail, I believe.
Oh, of course,
yes, this is for my own tail. So before I wasn't tail chasing. And if I tied myself into a knot and my tail was beside me, I wouldn't know that it was a safe space because the tail moves, so it becomes a safe space, right? Yeah, I wasn't making that check before. So I remember this is something that I added near the very end that really, really helped elevate the gameplay of my snake, that made it so it could get further. I noticed that was one of the things that was happening is I would know that my tail was safe, but it didn't. And I would just be screaming to myself, like, why did you go in that direction? You could have just gone onto the tail. So I put that check in.
Nice.
This, when I was going through my code, I'm not exactly sure why I subtract 1 from check for safety, which is our magic number 8. I'm not sure why I do that. I couldn't think of a reason for myself of why I needed it, but it's there.
It's there. I mean, chat, if you've got any theories about past Austin, something I say a lot is like you want to try to write code. Like you want past you to write code such that you want that future you wants to give you a high five.
Yeah.
But like sometimes leaving mysteries is so if anyone can figure out what past Austin was thinking.
Because this was one of the last things I put in. Normally I think I would comment something like that, but because it was one of the last things I put in, I think I was running out of time a little bit, so I just kind of left it, and now I'm not sure exactly what it's doing.
If you remove it, what happens? If you don't remove it, now scared to find out.
So that was the check for our own tail. Am I going too deep into this? Should I be going a little bit faster through it?
No, I mean, this is interesting. Like, I mean, just to kind of like summarize the high level, because I think especially for like folks who are just starting in Battlesnake or who are competing kind of in that gold level, what I found interesting about what you've described to us so far is like this is the part that's deciding whether or not it can move into a square. And usually, like when you do your starter snake, it's just, is it open right now or not? Right? Like that's your like V1 battle.
And that's how exactly how I started out too. That was my V1 also.
Nice.
Yeah.
So this is interesting now, calculating a few ahead and then the stages that you've added. I actually really like how it's broken down into that organization. Like first step is like, is it empty now? Is it probably empty in the future? Then like, but wait, what if it's a wall? But wait, what if it's another snake? But wait, what if it's my own tail?
Yeah. And this is just one part of all the checks that I do. So this is basically just our check to see how many spaces we have in each direction. And then on top of that, I do checks to see, okay, will a snake's head be there if I move in that direction? Is there food there? Is this going to move me onto the edge? Which is one of my strategies that I came up with later on, which we can get into once.
Nice. So yeah, so maybe a question, because it sounds like you're in like a hybrid stage, because like early battle snakes often, I call them rule-based battle snakes, where you're just looking and you're like, is the next square my tail, or is the next square this, then do that. And that's very like rule-based. So it kind of sounds like inside of your pathfinding algorithm, you've also injected kind of some very like hard rules. Is that accurate?
Yeah, I've definitely done that. Yeah, it's definitely a rule-based snake.
Yeah, along with this algorithmic add-on. It's like just starting to dive into that, which sounds like a good threshold.
This recursive method is one of the last things that I did. And I thought I was so fancy putting it in. I was like, oh yes, this is so perfect. This is exactly what I need. It's so high level.
You're doing computer science now. There's recursion.
Yeah. I realize now that like at the time I had the thought that there may be snakes that do machine learning, but now like I actually know that that's what happens. So it's like, oh, this is not that fancy.
No, but it is such an important part of the journey. Like if you're just diving in at the end, it's going to be hard to kind of pick everything up. It's a journey.
Yeah. And if I had more time, like if I had started right at the very start and I had more time to put in, I think there was a lot of things that I had in my mind that I wanted to do that I thought would really, really help, but I didn't get the chance to make it. So if I were to do it again and start from this code base, I think that maybe I can make it a little bit further. I don't know if I'd make it up to what is the last one? Elite or Platinum? One of them? I forget what the highest is.
Well, Platinum's after Gold, and then Elite is the
Elite. Okay. I don't know if I'd ever make it to Elite, but I think I can make it a little bit higher than where I did before.
Yeah. Are any of these thoughts, like the expansion, any stuff you want to share, or are you going to keep that close?
No, I can share, definitely. Well, the one thing that I mentioned is almost trying to simulate the game board where the snakes will go. Like in this recursive method, they're just kind of static where they are, and I'm doing a check of the board. But I'd kind of like it to be where on each node check, simulate the snakes move on the board to see where they will go to try and make it so that it's a little more intuitive, and that if there's about to be a cutoff, and that way would actually only be 3 squares. But right now, because it's 1 away, it's 8 squares. I would want to simulate that so I could say, oh, this is going to be blocked off. We need to go the other way instead of trying to go that way. That's where I would go next. Which
interesting, nice.
I think I had that thought at the time, and I wanted to do that, but I just ran out of time.
Yeah. No, that sounds good. I mean, even just that one goal sounds like there's a fair amount of iteration and modification, even just that one little step.
Yes,
it's not a little step, it's a big step.
That would be a very, very big one. So where were we here? So this is enemy tails will also be valid moves. Yeah, so this is where I check enemy tails too, because that's also a safe space if they have not eaten. So
yeah, that's what I was just checking for.
Yeah, I also have that in here. So if the last 2 positions in the vector are the same, the snake just ate food, so that is no longer a safe position because it will be the snake's tail still.
Nice.
Yeah.
I can almost see how that got added. Like
after testing, yeah, I was going through a snake's tail and it ate, and then I died, and I was like, oh right, I need that. Let's see. So, if this node is currently occupied by a snake's body, it is not a safe move. Oh, right. This is another place where I didn't know exactly what I was doing.
Awesome.
Because if you look at this if statement here, we're checking the current position. So the current node we're on, all these checks that we're doing are for the neighbor nodes where a valid move will be from that position. So
Okay.
I don't know why I'm checking the current node and not the 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 neighbor chord from the for loop that we're in.
Yeah, I feel like wouldn't this always return false? Like,
yeah, that's will it? I don't know. This is the code that was in when I won, so it's doing something that's working. So,
or it's just not executing, but one of the two, right? Yeah.
One of the two, yes, maybe. But going back through it to see what it's doing, I'm not exactly sure why I'm checking the current position instead of the neighbor position, which is the ones we want to check.
Right.
So there's probably a little bit of a bug that's happening, but it doesn't affect a lot, I guess.
Fair enough.
Yeah. So this is just for setting that direction to false if there was a snake body there. So yeah, so that's what that part's for. And then I believe that's the end of that method there.
I mean, that's pretty meaty.
Yeah, that's the recursion part of it, I believe. The one that's what's very important, which is why I don't like that I don't know what's going on here, because that was a very important step that was happening. So let me see, what are we doing here? Check to see if we've already checked this chord. Yes, so this is where I'm making sure I don't go in a circle. Like if we have 4 grid squares, I don't want to check the same 4 8 times and say, yes, there's 8 valid moves here, and there's only 4.
Right.
And this is another big nested for loop here. For the chords of the nodes we have already checked, okay. If the valid move chords and check chords are the same, we can't move back onto this node. Our body will be here.
Oh, of course, like as you move forward. Yeah.
Okay. I'm trying to think about what the code's doing in the as I'm reading it.
Yeah.
And it's difficult. It's difficult when I know I have people watching me. It's difficult.
No, that's okay. I'm guessing there's probably, trying to see what your scroll is, there's like 2 or 3 more logical sections where you're kind of high level, like checking for your own body as it moves and
current position dot second checked move. So if the valid move chords and the check chords are the same. Oh, right. So this is just saying if we found one of the checked moves as the valid neighbor chord, that move is false. That's what stops us from checking the same node twice, basically.
Right.
So that's what that's doing. And then this, I believe this is the actual. So if I skip over this quickly and I go down to the very bottom, this is where the actual method is being called. So
right, all of that code bundled up.
Yeah, this is our first 4 nodes. This is where we start the method from. So the method that we had just gone through is this right here.
Yeah.
So we're checking each direction. So there's 1 for each direction, which I could have only done 3, but
no, that's fair. That's fair.
Yeah. So this is where it's called from, and then this is where up top, the 4 different variables that I showed you that hold the number of safe moves, that's where the recursion starts. That will update those 4 numbers up there.
Yeah. And then you get a clear path. Can I move 4 up? Can I move 5 right?
Yeah.
Can I move 6 down? Yeah.
And then I think if we jump back up here now, I don't know if this is probably we're jumping all over the place, so it's a little confusing, but so this is where after we checked what directions are valid for this node, if the direction is true, create a new node with the valid node's position. So this is where the actual recursion comes into play. So if we've checked that direction and there's nothing there and it's a valid move, we create a node for that position and we send that node back through the function to do the checking all over again for that node's neighbors.
Right. So it keeps drawing the box around of itself, making sure not to do any overlap, double checking. Yeah.
Yes. So that's where the recursion comes into play. So maybe now it's a little bit more, we can understand more what's happening.
Yeah, I definitely find that, like, to understand any small part of a recursive function, you have to understand all of it first.
Yes.
It's a weird chicken egg problem the first time you go through it.
So
I follow.
I've commented this also. So here's where we're creating the new node. We add the coordinates that correspond to this direction of travel.
Right. Because then you'll know whether or not, like, if you started at 5, 5 and now you're looking at 6, 5, then you can kind of compare. And
and then we know that direction is 6. Would that be left or right? I'm not sure. One of them.
That would be right. Yeah. Take a moment to think about that.
Yeah. So add the check nodes so we don't go in circles. Yes. So this is where we add our list of check nodes. Push back this current node's position to check nodes. Yes. So we've already checked this node's position. So now we push that node back into the check node so that when it goes through, it knows that we've checked that position.
And you're good. Yeah.
We set the direction of travel. Increase the safe move count for this node. So this number here is what corresponds to the 4 numbers that were up top that I told you about. So this is what will increase that number so we know how many moves are safe in this direction. And then this call, this is where the recursion occurs. So here we're calling that method again with this new node that we've just created.
Yeah. So to maybe simplify and recap, just in case anyone else isn't following yet. Mm-hmm. So, like, assuming you start in the middle of the board, like a 10 by 10, you're at 5, 5, and you want to check every square around you. And once you've verified that you can move right, say, you're like, okay, great. Let's just see if it's clear all the way. Like, if we kept going right, is it still clear? So then you now look at 6, 5, which is a square to the right, and you check all around it. But you have already checked 5, 5, so you don't need to check it again. And then you just keep looking. And every time you look at a square and you look at all of its neighbors around it, you have a lot of rules. Like, is there a body there? Is there a food there? Is it the edge? And you have to just run through that whole set of rules every time as recursively. And you go right, you check every square to the right. You go up, you check every square up as far as you can. And your threshold was 8, which... that's pretty good on a 10 by 10 board. That'll get you like most of the board.
Yeah.
So that intuitively feels like a good number. But if you're playing on a larger game board, you probably need to increase that number.
Yes. That is a number that you would have to increase if it was a bigger game board.
Oh, Extagon. Extagon says hi. They're late, but excited. Deep Learning's back. Thank you.
Oh,
welcome, Extagon. We're glad Deep Learning is here too. Yeah. Okay. So this is brilliant, Austin. Like, we don't have to go too much deeper because I think we've got the core concept of your algorithm here. And kudos to you for handwriting this like recursive search, adding your rule base in each one. Yes. I feel this is like a really good model of where to target your Battlesnake if you know you're not ready to be applying full machine learning algorithms, but you want to start dipping your toe in and developing an intuition. I think this is a really great example.
Yes, thank you.
Yeah. Are there any things that you've done here, either technology choices or things that you do that you're like really glad that you did that you thought were beneficial?
The thing that I thought was the most beneficial, the one that made me jump the furthest in the leaderboard, was the confidence ratings that I've been telling you about. Doing at first I had it so it was just a Boolean true false in each direction. Up true, we go that way, and then the rest are false. But I found that there's a lot of different situations that you can get yourself in where you want to know more from those Booleans, right? Like if there's a snake head there or there's a piece of food somewhere else, which one would you want to go for? Like there's a chance that you want to do both based on what's happening on the game board. So I just felt like a static true false go this direction wasn't the best option. So I made that a little more so I could have more variability in what I wanted to do. I feel like that's the one thing that I did that was really beneficial, which I can show you. It happens in this method here, which is my falsify moves method.
Oh, okay. So I'm guessing you started with Boolean.
Yeah, this is where everything started. So from here is where I started to build out everything. So that at first, when I first downloaded this, I believe it was just making random moves, and then I expanded it from there. So this is where the main part of what's happening is. So let's go up to the top here. And this right here is where I was talking about where you add and minus from the confidence ratings. This is the different numbers that will add, increase, or decrease the confidence for that direction.
Gotcha.
So we have one to avoid the edges. This is for avoiding another snake if that snake is longer than us and it could kill us. So that one's a very big one because you really want to avoid that way, right? So that's a huge number. There were times where I would want to avoid food, so I added an avoid food one. And these ones are all the negatives. So to make it easier for myself, I just when we do confidence, when we're adding to it, I just do confidence plus equals whatever one of these I want. And because these ones are negative, it will decrease it. So it's just easier for me to remember that in that spot, I don't have to say minus equals here and plus equals here. So I just made it easier for myself that way. So these are the negatives which you want to avoid. And these are the positives here, which will make us want to go in that direction. So if we find another snake's head at the position where we would want to move, that would be, and that snake is shorter than us, then that would be knocking them out, which is a good thing, right? So we want to go in that direction. So I add 25.
Nice.
And then this one here, the multiply safe moves. Remember how I told you about we check for 8 moves and then I multiply that by a number to get us a bigger number to work with. This is what that is. So I multiply that 8 by 100, which gives us a confidence rating of 800 to begin with.
Right.
There's 8 safe moves in that direction.
Gotcha. Wow. And I'm sure it was fairly, I'm assuming, experimental in picking these values and how strongly.
Yeah, that's where a lot of the watch what happens and then change the number to see what behavior changes in the snake. That's where a lot of that came into play.
Awesome.
Yeah.
Oh, that's cool.
We have one to go for food. We have one if the food is on the edge, which I explain later on. I have another one of those the little game boards that I made to explain what I mean when that's happening.
Nice.
We have a currently on edge one. So this one, if we are on the edge, get off as soon as possible. This is a positive because we actively want to get away from the edge. Yeah. So I remember thinking to myself, why is currently on edge a positive? Isn't that a bad thing if we're on the edge? But it's a good thing because I actively want to get off the edge. So I'm in a safer position. So that's why it's a positive.
Gotcha.
And then we have chase tail. So when we're not looking for food or enemies to kill, we just chase our own tails to survive.
Yeah, and that was pretty strong. We see that in those games, right? Where it does look like chase tail, go get food, chase tail. Like it flips back and forth between those, especially in 1v1 where you have so much space on the board.
Right, yeah. And then overrides. So some of these rules do not apply. Right. So some of the rules, remember how I was telling you that 30 is also a key number?
Mm,
If we are past the start, so before 30 turns, I allow myself to go onto the edge of the game board. And I
right.
believe this is the number that I use to say, okay, yeah, go onto the edge to collect that food.
Right.
I think I'll get to it if we go through this whole thing here. These are the actual numbers that I use for the confidence rating. So at the end, these are the numbers that it'll use to determine what direction we're going to move in.
Mm-hmm.
And then these here, this is just all my methods that I use to check and see the state of the game board.
Right.
I
I'm guessing I'm seeing distance, so like how far away food is.
Yeah. So maybe we can skip past all these methods and then come back to them as we reach them in the actual main part of the code.
I mean, I don't want to shock you, but we've already been talking for an hour, sir.
Have we really? Oh
I
my.
know.
Maybe I need to go faster.
No. This is super interesting. I mean, I genuinely think that your approach with the nodes, like that's really kind of the meat of your, that's a weird thing to say, but also, okay, I don't know. It's kind of the core of your Battlesnake code.
Yeah, I would
very
say that
cool.
was the core, yeah.
Yeah.
It was the most confusing part to do.
Yeah, and move through that, and even to understand the thought process and the complexity. So it's good. So I mean, I think this is a beautiful taste. I don't want to overwhelm folks.
Okay.
But is your code up? Is it visible for the world to see, or?
I'm not sure, honestly. It might be. I can make it that way if you want it that way.
In a GitHub repo? I mean, that's up to you. In Battlesnake, we love it when folks are willing to open source their code and let others learn from it, especially a C++ snake, which is not very common.
Yes,
so I think that's quite interesting. Yeah.
What are the most popular languages, actually? I'm not exactly sure.
Yeah, the top two, the most Battlesnakes we see are in Python and JavaScript.
Oh, okay, cool.
Yeah. That's generally what we see. So C++ is a bit rare, but fantastic to see. And like clearly you've managed to like build through and building a winning snake as well, which is very, very cool.
Yes.
Yeah, which is cool. So I mean, I think this is a beautiful taster, and thank you for sharing, for having a vulnerable moment of looking at your code and letting everyone see.
Yeah, absolutely.
for anyone competing in Fall League, do you have any advice or recommendations or thoughts for them?
Ooh, Maybe my advice would be, if you're not familiar with the language you're doing, don't be too hard on yourself, because this is just we're learning. This is for learning, right? Because I know that when I started, if my snake was not doing very well, I was really, really sad and really upset with myself that it wasn't doing well, and I had to think like, this is for learning. So we don't need to be super hard on ourselves, right?
Yeah, totally. Full agree on that one. Let's be kind to ourselves and enjoy the journey. Like enjoy the ups and downs, which you clearly had.
Yes, a lot of.
That is awesome. Well, I want to thank you, Austin, so much for joining us. And I'm so glad you had this journey through the RBC intern competition and then into Spring League. I hope we get to see RBC Serpent. Maybe in Fall League. It's not too late to join if you haven't.
Maybe.
Same goes for everyone else. So if you haven't joined Fall League yet, I'll just get the URL up here. But it is open. It is just started, so you don't have to do a 2-week sprint to gold like Austin did. You've got plenty of time to work on and iterate on your Battlesnake. So do check that out if you're interested. And I just want to thank, again, our partners, our Battlesnake partners, so AWS, RBC, and GitHub for helping us put these streams together. Thank you, Austin, for joining us. And glad to have deep learning back. Thanks for those of you who came and tuned in. Yeah, and if there's something you'd like us to do or something you'd like to see on deep learning, let me know. Ping us on Discord, send us an email at hello@battlesnake.com, and we'll do some more stuff of this. Or if you have a Battlesnake and you would like to expose your messy learning journey the way Austin did, I would love to have you as well. Cool. All right. Well, thanks, Austin. Thanks, everyone.
Yeah, thank you so much for having me.
Yeah, no worries. All right. Bye-bye.